Hello, everybody. G'day. My name's Hudson Worsley, Chair of MECLA, the Materials and Embodied Carbon Leaders Alliance. Welcome to another one of our spotlights. And today, MECLA is shining a spotlight on how to specify low-carbon clay and cement bricks, roof tiles, and piping. Glass in the title will be next year. Thank you very much for joining us. I'm joining you from Gadigal country of the Eora Nation, and I'd like to pay my respects to elders past and present, and to welcome any Aboriginal and Torres Strait Islander people joining us today. We've got many people, I think over 300 registrations for today, so clearly another area of great interest to the MECLA community. I'd like to remind everybody, as I always do, that MECLA operates within a governance framework that ensures we are in a pre-competition environment. It's so important that we stay on the pre-competition side of things to make sure we're operating in the public interest for the greater good. And that greater good is to get the carbon emissions, embodied carbon of the construction sector in Australia down onto a trajectory consistent with the Paris Agreement. We do that recognising just how complex that task is and that the ultimate destination is a circular economy. So welcome, thank you for joining us. And I'm really looking forward to hearing these guides set out by the wonderful work from Working Group 5D, the other materials group. Look, so much work goes into this type of thing behind the scenes. So take notes as you will. We've got the Q&A function to ask questions. We've got the chat. Keep maybe comments in the chat and questions in the Q&A. We are recording this event, and like all others, it will go up onto the resources page. And through the resources page after the event, you'll also find a link to the guides that are going to be set out today. Now, I mentioned a future event. We will be having another spotlight on specification of low carbon materials, looking at glass and bitumen and plasterboard. That'll be in the new year. So stay tuned for that. All right. Now, for today's event, I'd like to hand over to Josephine Vaughan from the University of Newcastle. Josephine, you're going to introduce us to these templates and maybe set the scene, how they've come about, that it's industry, research, peak bodies. So much work's gone into this. Looking forward to hearing all about it. Over to you.
Thanks, Hudson. So hi, everyone. I'm Dr. Josephine Vaughan. I'm from the University of Newcastle, and I support Kathy Inglis as the co-chair of this MECLA Working Group 5D on Materials and Assemblies. And I come to you today from Guringai country, which is between Dungog and Gloucester in New South Wales. So our Materials and Assemblies Working Group is a microcosm of the wider industry. So we've got members who are material manufacturers, there's construction companies, industry association, peak bodies, government and university, and other research academics. So through our group, we know that there are many different organisations who seek to improve the ecological impact of construction through materials with low, zero, or even positive embodied carbon, as well as other favourable environmental outcomes. So our spotlight today addresses a missing link between these groups, which our group identified quite simplistically as information. We're missing the link of information that's easy to access, easy to understand, information about building materials that provides the detail and the ideas needed to meet the growing range of requirements for decision-making, design, construction, and reporting in the sustainability context. So together, our group developed a template or a specification guide for materials manufacturers to collect and share this type of information about their products. And that's what you'll see examples of today. And this template is available for anyone to access and use as they like. So together, our group identified the important areas of information that need to be shared. And there's a lot of quantitative information on there about embodied carbon values, baselines and benchmarks, environmental product declarations, circular economy, recyclability, reusability, and other ecological impacts of building materials. Also, the template includes quite quantitative information And it's quite unique, I guess, in that it captures what are the current barriers, particularly say for manufacturing companies. What are the barriers to reducing the embodied carbon in your product? What are the barriers to getting your product out into market, to getting more people to know about it, to purchase it, to procure it? And likewise, what are the opportunities that these particular materials groups or assemblies might have that they can tap into to move forward? Also, the strategies for selecting lower embodied carbon. What are the options if you have a client looking amongst your suite of materials? What are some tweaks that could be used to reduce the embodied carbon of that material? So this template is informed by feedback from our group as our material manufacturers and group tested it out, and we, as the kind of researchy brains, informed it. So it's relevant to current practice as well as future forward. So it includes a snapshot of where we are now. It places products in the context of the broader range of offerings, but it also helps manufacturers to create a roadmap to a sustainable future for their products. The template provides a guide for manufacturers, and as such, it was tested by the manufacturers in our working group. And as they worked through the template, they reported back to our group that it was a very beneficial process for the organisation to identify the information required, and it helped them to understand the needs of those looking to procure their materials. As you'll hear this afternoon, the template has been used by the material manufacturers in our group to provide clear information about their products. When you look at the base template that you can access and the results produced by our members, you can see how each member has adapted the format and the presentation of the template in unique ways to best get the message across about their product. And this will give you ideas how the template can be used in different ways for different needs. So let's have a look now. Hudson, if you'll introduce our first presentation.
Thanks, Josephine. Terrific to hear that background and the breadth and depth of information and work that's gone into the guides. All right, Jack Gill, over to you, General Manager at ThinkBrink Australia, as well as the CMAA and the ARTA. Any other acronyms you'd like to throw at us while we're at it?
You can throw in, and no, that'll do. That'll do the job.
So what do they stand for? CMAA?
So the Concrete Masonry Association of Australia.
And the ARTA?
The Australian Roofing Tile Association.
Brilliant. All right. Glad we got the acronym soup out of the way. You're going to talk to us about concrete bricks and roof tiles. Brilliant. Over to you. Thanks, Jack.
Thank you, Hudson. So with any luck, this is now sharing these slides for everybody. So
not on slide view yet, though. There you go.
Wonderful. Well, here we are. We've got it now. Thanks, Hudson. And thank you, Josephine, for that bit of introduction and context to these specification guides. And today I'm going to be talking to you about our embodied carbon of concrete masonry and roof tile products. So to start, I'm joining today from lands of the Camaragal people on the wonderful North Shore of Sydney. And it's absolutely wonderful to be here. And I want to pay my respects to elders past, present and emerging, and extend that to any Aboriginal or Torres Strait Islanders here today. So as Josephine alluded to through her little bit of an introduction into these templates, what we've been working on in Working Group 5D is looking at how we can kind of pull together all of the information that we have as manufacturing bodies for the materials that we represent, and essentially showcase all of that information on embodied carbon, circularity, and the processes that we're undertaking with our manufacturers to see how we can get that all in one location to make it easier for specifiers and designers to use this when they're looking at new projects. So when we're looking at these guides, and Josephine's had a really clear presentation on what's included, but just as a bit of a recap for you all here, what's inside these guides that Alexi will upload and show you throughout today's spotlight. We look at, first of all, the different measures of embodied carbon, so how we actually measure embodied carbon, the different databases and profiles that are available, some of the baselines and benchmarks that have been set from each of our manufacturer members, so where we've come from in the world of embodied carbon, as well as where we're actually going moving forward. Next, and really important, the barriers and the challenges that we face, not only as an industry association, but what our individual member manufacturers actually see in terms of trends, and what those opportunities and potential solutions are for decarbonisation. And you'll see that this is where for concrete bricks, concrete roof tiles, whilst they are different products, there is quite a complement between some of the strategies that we can employ across our industry. And then as we're coming along that journey, what are some of those carbon reduction strategies? So what can specifiers, what can designers do right now if they want to use a concrete brick, concrete block, or concrete roof tile? What opportunities do they have to actually reduce their carbon footprint right now? And moving forwards, what is that trajectory going to look like for them? And then importantly, and for us as an industry association, those last two dot points at the bottom there on circularity and the story beyond carbon are also really quite important. And I think that's what gives a lot of strength to these specification guides that MECLA has produced, is that they not only look at what the carbon story is, but they look at where the other portions of sustainability fit and circularity, and give a more broader picture of where each industry sits. So I guess the question that we first had to look at as Working Group 5D was, how do we actually pull all of this information together? And this was one of the real difficult challenges when we first went along this journey and we started to pull these templates and fill them in with the meat of the document, if you will. And for us at the Concrete Masonry Association and the Roof Tile Association, the first step was actually bringing along all of our manufacturers on this journey. So actually getting the people that work at our factories, that understand the products at a very specific and sometimes scientific level, bringing them into the conversation so they could share not only a little bit of the background of how these products are made, but some of those really nitty-gritty case studies that actually quantitatively show the reduction towards decarbonisation. So once we had all of that information, we actually produced our own industry sustainability strategies and roadmaps, which are available on our own website. And these essentially document that carbon and circularity story and provide some case studies and information on where the industry is heading. And so when it came to working with MECLA on these templates, we were actually able to use a lot of this information that we pulled from our members and actually fill that into this template. And I think this goes to what Josephine spoke about in her introduction, was that undergoing this process of creating this template in of itself actually gave us a lot of education that we not only got from our manufacturers, but were able to then give back to them as well. So one of the key successes of this journey, from our opinion as an industry association, has actually been getting this information together and understanding how we can present that and educate our own members and our own manufacturers on their sustainability journey. And so from there, when we actually open up this template, and you'll see as you're accessing this template now and in the future, it goes through and talks a little bit about what the carbon story is of concrete products. Now, what's worth knowing is a little bit about that actual manufacturing journey. So when we look at our carbon narrative, we're specifically at this point as an industry association looking at what we are doing from the raw materials through to the manufacturing stage. And so you can see here on the screen in front of you, this paints a very small and somewhat simplified picture of what actually happens when we're making concrete bricks, concrete blocks, and concrete pavers. And it's really important to have this kind of visualization, because this is where we start to understand where the carbon comes from and where our embodied carbon component lay for our concrete products. So you can see there we have our cement manufacturing process on the left-hand side down the bottom of that chart, where we're actually getting our raw materials, we're producing our clinker, and we're getting our cement. And then when we're making our concrete products, this is actually the combination of that manufactured cement, along with any aggregates, water, and supplementary materials, which are then pressed and shaped into our concrete blocks, our concrete bricks, and our concrete roof tiles. And these are then cured and then they're ready to go. But if we delve down a little bit deeper and understand the concrete fundamentals, which I'm sure a lot of you are familiar with, we then start to understand that the carbon component and our embodied carbon of our concrete products lies primarily in our cement usage. So clinker production, where heating limestone and other minerals to above 1400 degrees, this accounts for over 90% of our total CO2 emissions in cement manufacturing, which is then in turn the major component of our carbon footprint for our concrete products. So when we're looking at our decarbonisation initiatives and when we're looking at our carbon numbers, which we'll get to in a second, it's worth noting that a bulk of this comes from our cement production or our cement usage. And so when we're looking as an industry about our decarbonisation journey, we need to understand how we can reduce this component. So when it comes to measuring embodied carbon, there are quite a few different sources and quite a few different ways that we can measure the embodied carbon or carbon footprint of a product. And a lot of you in this room online will be familiar with environmental product declarations or EPDs, as well as industry reports and industry average figures, as well as materials databases that look at and pull together different sources of information to provide a conservative estimate on those carbon footprints. And so within the template, we've actually got a quantitative table that actually showcases some of those actual carbon figures for a range of different products that our Australian manufacturers make here, as well as some of those conservative database estimates that pull together that process data. So you can see that from the left-hand side, numbers can vary from 0.12 kilos of carbon dioxide equivalent per kilo of product, all the way up to 0.26, depending on what database you're using and depending on what product you're using and whether there's an EPD or other carbon data available. And it's worth noting at this early point throughout today's spotlight that when we're comparing carbon, it's a bit of a misnomer term. We do have to be really careful about what we're actually comparing and whether or not they are equivalent. So throughout the template, we talk about what is actually included in these numbers and how you might go about actually looking at where these numbers are appropriate to be compared. And again, you'll notice that the declared unit for these products is in per kilo. And when we're looking at concrete roof tiles on this next slide here, we have to be a little bit careful about how that actually translates from per kilo of product to the application of a whole concrete roof. So when we're looking at meters squared of roofing. So again, these numbers are really great to have and great to be able to give you an introductory showcase of what carbon estimates we have and the trajectory moving forwards of seeing these numbers decrease. But I also urge you all to make sure that you're aware of what is being compared and what the declared unit of that product is. So in terms of baselines and benchmarks, we also look at what some of our concrete masonry members are actually doing right now and what they've set moving forwards. So to give you a rough indication, so two of our largest members, we have Brickworks through Austral Masonry. They've already had they're aiming for a 15% reduction in scope 1 and 2 greenhouse gas emissions by 2030, and that's against a 2022 baseline, as well as an increase in up to 20% recycled material. And similarly, with Adbri Masonry, they're looking at a 7% reduction in GHG emissions by 2030 against a 2020 baseline, and a large reduction in those cement scope 1 emissions. So again, goes back to that point that we made on the cement production going into our concrete products. And so through these templates and documents, we can actually showcase those manufacturer journeys as they happen. So some of those barriers, challenges, and solutions, and this is where these templates differ to a standard environmental product declaration, because they actually do showcase what some of the barriers and challenges are. So as mentioned before, the high cement content in these concrete products that's something that is one of the largest hurdles that the industry is working on to see if we can reduce that, as well as looking at alternative energy sources to decrease that overall carbon footprint. And throughout all of this, we need to look at how we increase our efficiency and increase the output of our products, as well as what's actually going into them, and how we do that in line with changing government and environmental authority requirements. And so when we look at these opportunities, this is where it gets quite exciting as you read through these templates, because you begin to understand where the industry is going, and what some of the really interesting projects are that are starting to get underway. So already in some of our members across Australia, we have many of our manufacturers investigating supplementary cementitious materials to decrease that cement component. So looking at things like fly ash and slag as a starting point. And we've got more research projects with different SCMs. We're also looking at further research in other areas to try and produce even lower and sometimes zero carbon concrete products as well. And as an industry body, it's our job to educate our members along this journey and help with easing some of those restrictions to increase manufacturing efficiency and flexibility for what types of products we can make to meet industry demand as it changes and as the conversation continues to shift towards this decarbonisation narrative. So further carbon reduction strategies, which are documented in more detail, include alternate product designs. So considering thinner products and considering mortarless products, so where we have concrete bricks and blocks that don't need to be mortared in, having more efficient curing regimes where we might have natural curing, designing more efficiently with products so that we actually are reducing wastage, as well as having renewable energy on site. So again, all of these small pieces come together to form a part of that carbon reduction strategy across the wider industry. And so towards the end here of my presentation, I want to give you all a bit of a quick snapshot on circularity, which I believe Kathy will touch on in a little bit more detail for clay bricks and clay roof tiles. But when we're looking at carbon, we need to then consider the circularity standpoint of what's happening from resource through manufacturing, through the use phase and to the end of use. And wherever we can reduce and reuse products and recycle products into new application, that's going to increase that circularity narrative. And so already our manufacturers are being able to crush up old concrete units and old concrete tiles to use as aggregate, whether that be in new products or be in road base for other applications, as well as on the resource side, looking at how we can actually increase the amount of recycled aggregate that we use in concrete products. So there's a full story and a full chart on circularity within the templates that I encourage you to read to give you a bit more of the full picture. So what else do we do now? What is the story moving forwards in conclusion to the start of this template? Well, the first step is having you all here today. So getting you to have a read of this and understand where the industry sits right now and where we're moving going forwards. Having us understand some of these new regulatory frameworks and be able to pass these along to our manufacturers. And while we're going along that journey, getting more support, whether it be from groups like MECLA or whether it be all the way up the chain through government. But ultimately, across all of those 4 dot points, what needs to happen is more research and more innovation across the industry in all 4 of those sort of dot points. So what we're aiming to do as an industry body is continue to push and encourage both our manufacturers as well as our research community to continue building this bridge towards that decarbonisation endpoint. So this is a really great snapshot to get you introduced to what the concrete, masonry and roof tile industry is doing. And I look forward to any questions throughout the latter half of this spotlight. So thank you, everybody. I'll palm it back to Hudson now.
Jack, thank you. That was terrific. Gosh, so much collaboration has gone into that. I know MECLA is all about collaboration and recognising that no one party can change this on our own. But boy, you've really herded the cats to bring people together. Thank you very much for that. stand by to be on the panel once we've heard from our next couple of speakers, but appreciate your efforts to date. And yeah, thank you very much. That was a great presentation. Now, Cindy Bray is joining us from Warsaw. My goodness. The commitment that's gone into getting this, you've worked so hard on this that you've even woken up extra early on the other side of the world just to make sure that it gets delivered. I really appreciate the level of work and dedication you put into that, Cindy. So you're executive manager at Piper, the Plastics Industry Pipe Association, and will talk to us about plastic pipe spec. But tell me, what on earth are you doing in Warsaw?
Hi, Hudson, and thank you very much for that introduction. Yes, it is very early here. It is just gone 5:30 in the morning. So when I spoke to the panel this morning, I was like, I don't know what time it is. I don't know what day it is, but I'm here to present to you all and tell you all about what we're doing in the plastic pipe industry in Australia. I'm actually here in Warsaw. I sit on a global plastic pipes conference organisation committee, and we're all together here to talk about our next conference. And a really big focus for us is sustainability. So being plastics, we can be deemed more negative than positive. So our industry is very dedicated to continue our sustainability journey. And that's another reason why we're part of MECLA, to be able to educate and inform and also show what we're doing, like everyone else on that journey, to reduce our carbon emissions.
Brilliant. Well, that's a perfect segue. I'll hand over to you for your to talk us through the guide on plastic pipes. Thanks so much, Cindy.
Thank you. Now let me just make sure we're all good. Okay, great. So thank you very much. And Jack, that was a great introduction into, and Josephine, into our specification guides that we've done. And you'll see that as Josephine said, that each of our groups were very different, and our product groups. So we have modified the documents slightly, and you'll see that through what you've just seen in Jack's presentation to mine. So let's kick this off. So again, I won't go into this into any great detail because Jack did a great job of explaining it. But again, throughout the plastic piping guide, you'll see we'll talk about the measures of embodied carbon, again, those baseline and benchmarks, the barriers and challenges and those industry opportunities, the carbon reduction strategies and circularity. So being the industry association, I am huge on collaboration with all of my plastic pipe members, and that goes right from the raw material manufacturers through to the pipe and fitting manufacturers, all the way through to the installers. So we have our association membership is very broad, and every one of them are on their own different journey. And so as the industry association, we help bring that together to tell our great story and our great journey towards, again, reducing our carbon emissions. So I thought I would start off just to set the scene for everyone. So has everyone ever stopped and thought about the role that plastic pipes play? And it's kind of one of those things that we don't actually think about because the majority of them are under the ground. So they're put under the ground and they're set there, and you know their service life is in excess of 100 years. So they're kind of silently working away, improving our lives, and we don't really think about it. But they do deliver our drinking water, gas, and electricities to our homes and communities. They also protect the network of wires and cables that deliver our internet. They're used in irrigation to grow our food. And more importantly as well, they also carry away our sewage and stormwater, protecting our communities. So I always say when I'm talking, I've got this great analogy that if you ripped up the road, underneath there's this vast highway of pipes, and they're all in different colours, and they're delivering all these essential services day in, day out to our homes and our communities. So they're actually an engineered product. And I just want you to think about that as we go through, because not all plastics are the same. Ooh. Oh, sorry. Excuse me. So I thought the best way to start was actually to look at the way that we actually do look at that whole life cycle of a plastic pipe. So you can see that little diagram on the screen. And we've taken and we've broken down the life cycle of the pipe by sector and their contribution to GWP. And this is all based on the work that our industry has done on EPDs. And so you can see that A1 and A2, which is the raw material manufacture and transport, and A3, the actual manufacturing of the plastic pipes, that's our most carbon intensive section. And that represents about 70%. And as you can see there, A1, which is the raw material, that's the largest sector there. it's quite interesting to note that the use and maintenance stage, which is that little light blue one right up the top there, that one is the least carbon intensive, but it's actually the longest time frame of the pipe. So that's, you know, when it's in its life, doing all those things I just spoke about, you know, for that in excess of, you know, 100 years. But what this does is when we map it out like this, it actually provides a really good baseline for us to be able to set and look at what we need to do and where we can work on to reduce our carbon footprint. And I did speak quickly about EPDs then. So we have worked really hard as an industry, and we've now gone through our second time of producing EPDs, and my largest Piper members, which is Vinidex and Iplex, have produced EPDs, which are available on their websites and the Piper website. A bit of a side note, I used to work for Iplex Pipelines, and I was actually part of the team that developed the world's first plastic pipes EPD. It was a huge achievement. Nearly 10 years ago now, but it was really interesting to be part of this journey again with the members at a different level to go through when those changes. And Jack made a really good point about, you know, looking at the units of measure and that comparability of products. And Piper is actually working at the moment on an infrastructure and drainage report where it talks about, you know, how to compare and how not to compare, and putting those comparisons, all those numbers in context when you do pick up two EPDs, because we do think that that is a really crucial part where people are focusing on wanting to use less carbon intensive products, but making sure they're actually understanding the data that that is available. And these will be published early next year. So, so what we did is, and this is just a snippet out of our actual document, is we looked at all the different types of plastic pipes. So they are structured and delivered in different ways. And as I said, not all plastics are the same, and not all plastic pipes are the same either. So we have our structured wall pipes, which are our corrugated pipes. And then we also have pressure pipes, which are used to deliver those drinking water, gas. And then we have your non-pressure pipes. So those ones they just are gravity fed. So you've got like your stormwater, your drain, and your telecommunications pipes as well. And what we've done is we've looked at the EPD's values, and then what we've done is we've provided a range there, because it will depend very slightly depending on the manufacturing capabilities, the footprint of where the factories are, and all of those other considerations that come into play. There are other databases out there that do have made calculations from sort of global databases on plastic pipes. But the fact that we actually have two of our members that have undertaken EPDs, we felt that that's the framework that we should be working on. And we even know that these could be improved again with our raw material suppliers if they actually undertook their EPDs, and I'll talk about that a little bit further on, that we could even get this number probably lower again as we do use a global database for that raw material section of an EPD. So as Jack was talking about with baselines and benchmarks, so as well with the Piper members, we have our EPDs, and we are working with some of our other members to produce EPDs as well. But because we have such a broad range of membership base, everyone is on their own journey. So what for this document and through collaboration with our members, we did have a look at what some of the key things that some of our members are doing. And as I said, everyone's sort of on their different journey, and that can depend on, you know, the size of the company or, you know, or what part of that circle framework that they're involved in. But some of the things that our members are working on is setting their targets to scope 1, 2, and 3 emissions. With one of our larger companies, Vinidex, they've actually come out quite bold with some of their targets around using renewables and setting their targets. And they have a great section on their website that talks through what they've been working on and where they are looking to achieve. The other areas that we're looking at is reduction of waste and you know, recycling of water, which if I take a step back, the actual manufacturing process of plastic pipes is really quite simple. It's pretty much, and I say this in very simplistic terms, but it's the plastic pellet or powder, electricity and water. So as we'll see through here, there's some really great opportunities there. One thing is having closed loop recycled water on sites, which is all members do. We also reuse all our rework material. So when there's a startup of production, none of that goes to waste or a landfill, it gets reground and reused. But we don't classify that as recycled content because it's just reworking of materials. The other areas that we're looking at is obviously increasing the use of recycled content, and I'll go into that a little bit more, but also looking at packaging as well, and what can we do to reduce the use of single-use packaging, and there's some really great innovation out there. And I think that's one of the great things about this, is that this is fostering innovation, not just within our products, but the whole life cycle. So one thing that I did want to just highlight, and I think it's really great, again, why we have these documents, because we have an opportunity to educate. Not everyone is an expert in plastic pipes. So it's great that we can be able to provide that information and context and understanding, and also understanding that there are industry associations out there that can help and assist as well. We have lots of great content on our website. So if there's more you want to read about, please head out to our website as well. But as I said before, going back to that first slide around the important role that plastic pipes play in our everyday lives. So it's really important that when we do use recycled content, that the product's performance is equivalent to as if it was using 100% virgin material. And with a focus on using a lot of recycled content, Piper has produced a discussion paper which really sets an understanding about using recycled materials in plastic pipes. And we've also done a more technical specification about how to actually use recycled content in pipes, plastic pipes. So within our Australian standards, you can permit use of recycled materials in our non-pressure pipes, but in our pressure pipes, we need to understand that full traceability. So at this stage, you can't use any recycled material in our pressure pipes. However, there's lots of great things we can do in the design aspect to reduce the amount of virgin material used. The other thing is, as well, is that they all need to meet the requirements of the Australian standards. And that's really important, again, because of that performance. We want them to last a long time. And that's where the factors of the circular economy practices come into play as well. Because we are long life products, recycled content availability is low. So majority of the plastic pipes that are in use now are in their first life cycle. So we kind of already have a solution where we can use recycled content, but we just don't have the appropriate material available now to use across all of our products, but we do use it, and I can talk about that a bit later. We have done some calculations though around if we did use some percentages of recycled materials, what would that look like to reduce our reduction in GWP? And so this is just two examples, and these again are in our document, and it looks at polypropylene pipes and polyethylene pipes. Again, there's not a whole lot of polypropylene raw recycled material available, but we are seeing, and there are products available where we can use recycled content, or there's recycled content available for our non-pressure polyethylene pipes. So that's like your drainage corrugated pipes that can go under the road. Like anything, there's various challenges, but also, great, again, like I said, to look at solutions. So as I've just sort of gone through, the availability of recycled material is low. So we need to focus on our raw material. And so our raw materials suppliers are looking at how they can reduce their embodied carbon. Obviously, it is derived from fossil fuels, but they are looking at bio-based, looking at other ways that they can use different recycled materials at that production stage. However, that's a really long process. So we need to be, as much as they're working on that, we need to also look at other areas of how we can reduce our carbon footprint. Again, the availability of suitable recycled content. So we do have recycling programs. And again, it's just that awareness and education that, hey, plastic pipes are actually 100% recyclable. So, how can we improve that? A cultural and behavioural change. Again, at that end user stage, it's whether they decide to put that little offcut into landfill or find a way that they can recycle it. And the industry is working with the value chain all the way through to improve that and to educate and change and make that behavioural change, but it can take time. Capital investment, it's economy. So we need to be looking at, how do we fund these projects, and and again, it's not just one sector, it's the whole sector that needs to work together there. And research and development. As I said, being a plastics industry, we're very focused on our sustainability commitment, and we're always looking at and undertaking research and development on how we can improve our sustainability practices. So I've kind of touched on some of the opportunities then as well. So we're looking at ways to decarbonize throughout the sectors. As I said, with manufacturing plants, it's basically pellets, electricity and water. So, you know, we can look at renewable energy there as well. We are in the development of a plastics products stewardship scheme for pipes and fittings, so that we can showcase that whole value chain of what we're doing throughout the whole the life cycle of the products as well. And I briefly spoke about the development of the EPDs and the interpretation guidance as well. And then looking at ways to reduce the carbon reduction as well. So again, with the raw material supplies, looking at that alternative materials, even looking at recycled content. So again, that specification is really important for pipe manufacturers, because maybe there's another material that's suitable out there. For example, PVC fencing. If it doesn't have any lead stabilizers in it, you know, we can reuse that into the core of PVC non-pressure pipes. You know, always looking at ways to invest in electric hybrid vehicles. Pipes are big and bulky, they carry a lot of air, and they're transported by trucks. And there's other ways we're looking at that as well by, you know, looking at our transportation by nesting. So you get more pipes on trucks because you nest the pipes together. As I said, renewable energy. And then also looking at carbon offsets, where at this point in time, maybe there's not another alternative solution. But again, there's lots of opportunities and strategies, and these will change over time as well. And I think that's one of the great things about these documents, is that over time the working group will be able to update and provide even more information on what all of the different sectors are doing. So just before I wrap up, I just really wanted to explain how plastic pipes actually fit into a circular economy framework. So we still have a lot of work to do, but in some of the main principles, we're actually already there. So if you think about the design and make stage, it's all about designing a product that can be in use for a really long time. So as I showed in that first little diagram, you know, in that use stage, you know, where we've got the most reduced amount of carbon is actually because of the fact that we've designed that engineered plastic pipe to last a really long time. So as I said, in excess of 100 years. And through our manufacturing processes, they're clean. Obviously, you know, we've got areas to improve around using renewable energy, but, you know, we're reducing already by using our rework materials. In the use stage, so again, selecting the right product for the right application will help, you know, keep that long life as well. And also keeping that product in use for as long as possible. In the reuse and repair, so we actually have a product that we already have repair options available. So to a point where you might not even have to cut out a section of pipe, we can just do other repair methods as well. And, you know, when we look at the reuse, as I said, we're still in our first life cycle. But after that 100 years, that pipe could become a host pipe for a new pipe. So it can have its life in a different way over again, but we're just not there yet. And then obviously recover and recycle. So if we do recover, plastic pipes are thermoplastic, so they're 100% recyclable. And then we can then put them back into a product that's going to have the same life span as one that was 100% virgin material. And so in some areas, we're doing that with offcuts now. But again, there's lots of opportunity there in the future. So that is all from me. I could continue to speak about plastic pipes for a really long time, but it's been great working with the working group and understanding and listening to all the challenges and barriers that each of the different products have had. And it's a great opportunity to present to you all today. So thank you very much.
Thank you, Cindy. That was terrific. So much information there, and really hearing so much from your industry expertise. So much appreciated. Please stand by. There are a number of questions in the chat coming through. Sorry, in the Q&A, not the chat. Comments in the chat. Questions in the Q&A coming through specifically on pipes. So maybe have a look at those, and we'll bring them up in the panel discussion shortly. Thank you very much. Have a cup of coffee. Keep you going all the way over there in Warsaw. And oh, well done. And we'll see you shortly for the panel discussion. Thanks, Cindy. Now, our final speaker is Kathy Inglis, who is co-chair of this fantastic working group. Kathy, you're the CEO of Brick Australia, but a long-time industry participant, particularly with Brickworks, which is how I've known you for many years. Thank you for, I think it was your insistence that we had this working group in the first place. So for that leadership, thank you. For bringing all of this together with your colleagues, thank you also. Please take us through the clay, brick and roofing tiles specification guide. Over to you.
Thank you, Hudson. And I'll just share my slides. Right.
Fantastic.
And yes, it was interesting because the first working groups were, you know, the big industry, concrete, aluminium, steel, and there were all these other construction materials out there that didn't fit. So that's when we sort of formed construction materials under 5D, so that all the other products could sort of be part of MECLA and we can all share the information across the industry. So again, I'm not going to cover off stuff that's already been covered because it's been well covered by Jack and Cindy and Joe to start with of where we've got to. So I'm going to cover off clay bricks and terracotta roof tiles. And our specification guide covers the very similar areas: measures of embodied carbon, the baselines and benchmarks, the barriers, challenges and solutions to that. The industry opportunities are out there, the number of carbon reduction strategies that are already in play and what's in the future, and then also talking about beyond carbon into circularity, and what we do also apart from carbon. So the others have mentioned before how much this has been a industry collaboration, and that was the really important part of this, to bring the whole industry together. So firstly is the MECLA working group and getting feedback from the other MECLA members that aren't specific product manufacturers, but they're academics like Josephine. There's other industry experts, the engineers and things that sit on our group. We're a very diverse group, and that sort of helped frame the template that was talked about. But as a clay brick industry, we brought all our members together to get them all to be involved with our the input into our strategy and into our specification guide. So the member collaboration across all our members are from around Australia, the education from the third parties that are on that working group, but also we brought in some experts to help guide our members through workshops to drag out all this information. It's surprising how much information manufacturers have, and they don't realise that's important to telling the whole story of where the carbon sits and what the industries are doing. And this part formed our industry sustainability strategies that are published. And this formed a great part of what we put into the MECLA specification guide. We checked many of the data points against external databases and did comparisons. And it was great that we worked with the other industries in our group. So if we look at the manufacturing process for clay bricks and clay roof tiles, it's essentially taking a raw material, shaping it into a product, drying it, and then firing it. And the manufacturing component, your A1 to A3, is the bulk of the contribution of carbon into the products. And that mainly comes from the firing part of the process. So as we go through, we mine and transport the materials. And if you don't know, most brick factories are located right on their clay source. So there's not a great deal of transport of the raw materials. The clay preparation, and then we shape the products either by extrusion or pressing. We have any surface treatment that goes on the products. There's quite a number of products that have additional glazes or slurries on the face. The products are dried, then they're fired. And the firing is the main carbon contribution. So if you don't know, most clay products are fired between 1,000 and 1,150 degrees, depending on the nature of the clays, the local clays in the area. That governs the firing temperature to get a vitrified product that has good durability. And then they're finally sorted and packaged and then delivered to site. The measurements of embodied carbon, again, this has been covered. Obviously, they're declared in environmental product declarations. The industry reports are averages or in material databases. So going through all that, what was declared by the individual manufacturers to what are the databases give you. This shows you the comparison of carbon numbers for clay bricks. From the lowest bricks that are available at 0.1 kilos per kilo, depending on where they're manufactured. The industry actually did an LCA back in 2008, and the industry average was about 0.2 kilos per kilo. Then we come up to, we've got our EPIC database numbers for process data at 0.25, the hybrid data at 0.32, and the neighbours data at 0.45. So there's a wide range, and obviously much better if you have products that have an EPD to be able to use those values, so you'll be able to report more accurately your carbon and report lower values. So if we look at clay roof tiles, again, there's actually no Australian manufacturer with an EPD at the moment. So I'm just giving you some averages for Australian compared to the Spanish tiles. We're 0.2, we've got Swedish tiles at 0.32, EPIC database process 0.39, and the neighbours at 0.68. So we know that the Australian manufacturers are working their way to having EPDs for the Australian made products, and they should hopefully be available next year. So going through some case studies, now I'm going to look at a bit about, unlocking where the opportunities are with carbon and what's already been done. So the Brickworks plant at Longford in Tasmania was transformed from using diesel into local waste sawdust from the timber industry that was going to landfill. This switch has annual savings of over 7,000 tonnes a year of carbon. And so this is the lowest carbon brick in Australia at about 0.1. And that's because of the reduced opportunity of all the energy savings in Tasmania by using biomass as a fuel. This plant has also reduced lots of other energy efficient projects. And the last bit they can't reduce, they're offsetting. So they're carbon neutral bricks and have been certified carbon neutral under the Climate Active scheme for the last 10 years. So the baselines and benchmarks of where we're at. So if we look at some of the larger manufacturers, firstly CSR, which have PGH bricks, they've achieved a 12.9% reduction in Scope 1 and Scope 2 emissions between 2020 and 2023. And they're now aiming to reduce their carbon 30% of greenhouse gas emissions by 2030 from their baseline of 2020. If we look at Brickworks have decreased their carbon emissions from the base year of 2006 by 56%, which is a huge number. And they've got further aim to reduce Scope 1 and Scope 2 emissions by a further 15% by 2030 from the 2022 baseline. BGC, which is Midland Brick over in Perth, they're now aiming for a net zero Scope 1 and Scope 2 emissions by 2040. So as you can see, there's a lot being done in the industry, but there's commitment now to this further reduction. So when we start to look at opportunities and innovations in the industry, there's many ways we can reduce carbon through manufacturing, but also through product innovation. So just some examples, looking at thin brick systems which are available on the market, bricks with increased core sizes. So both of these products use less clay, they're thinner, so they have a lower carbon footprint per square metre of wall. Mortarless bricks, so bricks going together without mortar. The ones shown there is a trial product that has plastic inserts in it, not on the market yet, but it's in development. But by reducing the mortar, that's a carbon contribution to the wall as well. But in addition to that, these bricks can obviously be disassembled and reused completely with their structural properties intact. And finally, there's a research project going on looking at mortar redesign, and that's actually partnered with Josephine Vaughan, who was the first speaker on this with Newcastle University and RMIT, looking at mortars that can be removed easier so bricks can be recycled, so reused, because bricks, once they're demolished in a wall, have their full structural properties intact and can be reused. So other ways that we're reducing carbon in the industry, there's clay and shale sourced from excavation sites, from construction, but also road tunnelling sites, which can substitute for the virgin raw materials. Waste paper, sawdust, coal fines and waste glass are already being added into products now. There's opportunities with organic waste materials, utilising byproducts and waste streams from other industries. There's trials about to happen using Grape marl, which is waste from the winemaking industries, from some landfill sites using their organic waste to put into bricks. There's also opportunities with lower fired bricks. And we fire bricks to that 1,000 to 1150 degrees because we want to make them more durable and withstand everything. If you ever look around some old buildings and things, you'll see bricks starting to fret and lose their bases. There were bricks made when the firing wasn't as well controlled as it is now. So they don't have full vitrification. So they will start to fret depending on the environmental conditions they face. But also alternative fuel sources. So organic waste competitions, there's lots of trials going on in this across the different factories around the country, but looking at what opportunities there are for local organic waste nearby their factories that are available. And when you put organic materials into the brick, you can put a lot of things into a brick and it all still has the same properties. But what's available, what it does, and you can still get enough structural and mechanical properties for it to perform well. But as it has a calorific value because it fires, it can reduce your firing requirements of your kiln, so you use less energy to fire the kiln. So it's a really good way to reduce the amount of gas used to fire and manufacture bricks. Looking at alternative fuel sources. So we already have factories, I mentioned, using biomass from the sawdust and waste sawdust industry, but landfill gas is used in several factories. There's now opportunities looking at biomethane from anaerobic digestion. And I know the planning applications have gone in for a plant to go in one of the New South Wales brick factories to be able to have renewable biomethane generated on site. And then there's also a bit of look at whether renewable hydrogen and can you make bricks with hydrogen or not. So looking at the circularity of the industry through manufacturing, as I mentioned, waste from other products are used, and but all the process waste in a factory is actually reused on site. Most of the factories run on full collected water use on sites. We've got big factories, big rooftops that collect water and can be reused. All the heat from the cooling end of a kiln is pumped into dryers through you can see there the pipes and networks that funnel that heat into the dryer so you don't use fresh energy. There's lots of solar going on to rooftops, electric vehicles in the yards, forklifts and loaders going into the yards, and also the opportunity for more renewable energy in the factories. We then look at the use stage and we look at through the life of the building. The most sustainable buildings are the ones that last the longest. So we want products and buildings designed for longevity. We need to build energy efficient homes, focusing on the passive solar design, and that these buildings will last for a long time. Looking at design for resilience and for low maintenance. And then finally, at the end of use of the products, as I mentioned before, bricks are one of the few products that actually be used with their full structural properties intact and reused once they're demolished. So at the end of the life of a particular project, demolish, reuse them. There's multiple brickyards that take back, clean the bricks and will sell them again for future applications. And you can see some examples there. There's also roof tiles taken off old buildings, are resold, and there's roof tile recycling yards that will sell roof tiles that have come off buildings. And if there's be able to be reused, if the products are too damaged, then they can always be recycled and you crushed as bricks and used for landscaping or other applications. But all the crushed products actually can go back into the manufacturer as the product as well. So there's a full circular story with clay bricks and clay roof tiles, and that's part of it. So not just looking at the carbon story of the actually embodied carbon product, but looking at it through its whole life cycle and through that opportunity of circularity. So thank you, Hudson.
Thanks, Kathy. Such a thoughtful process, and finishing on the circularity piece. That's where I started in our introduction. So a really nice way to round out the introduction to the guides. Can I ask the other presenters to now turn their cameras on? Hello again, Jack and Cindy and Josephine. Look, you guys have clearly put in a lot of work, but supported by your industries to make sure that what is put forward isn't just, one product or representing one part of the value chain. So much has gone into it, but it strikes me that keeping these things up to date is also going to be a very important part of the value proposition. Josephine, as the person who introduced the process and the template, what are the plans for making sure that these remain valid?
Point, Hudson. It really does need to be an iterative process that continues to grow and develop. And I think anyone involved with any of these carbon accountings is aware that they do have to keep, like Cindy said, they're already on the second EPD round, is that right? So it is something that needs to keep happening. I think as our working group, we can keep looking at our template as well to make sure it's still capturing what are the important things, and as things change, for example, different requirements from government, that increase the sort of information that needs to be shared.
And how do we prevent greenwash? It's very tempting for any organisation to put their best foot forward, to show their best side. How do we make sure that there's rigour to what's being put forward in these guides?
I think that really what the presenters talked about today, the way that they use this template to work together with their whole industry. And when people know that across the board, different groups are coming together to present this kind of information, that gives a real validity to the information. Also working with recognised research groups like universities. But yeah, that's definitely that reputation builds for sure.
Great. And look, that was a bit of a Dorothy Dix, because obviously MECLA has its governance framework to make sure that that we can be trusted, that the work can be trusted. But it's important just to confirm that. Who's the audience for these? Maybe each of you could answer that. But we're all passionate about reducing the embodied carbon in the construction world. But who cares? Who's going to read these documents? Jack, maybe you first.
Yeah, I think for me, this answer, from my experience with the development of these templates, there's really two key audiences for us sitting here as an industry association. The first audience for us is actually our manufacturer members. So bringing them along on that journey and getting them all together in a room and getting them to actually start having these conversations not only gets them giving us information so that we can present that, but it keeps them conscious of the fact that this conversation is happening and it's moving forward. And I think it speaks a little bit to your question earlier to Josephine regarding how these stay updated. By continuing to have these and push them out to our manufacturers, it keeps them honest and it keeps them on it to keep these updated. And then as a secondary and perhaps even more important audience, it's the specifiers. It's those that are actually looking at materials going into projects and being conscious of where their carbon numbers start to add up across a project, and understanding that carbon is a very important component of sustainability, but the discussion is more nuanced than just looking at the initial embodied carbon, and that it is about circularity, it is about the operational requirements of a building. So I think there's a broad audience, but yeah, manufacturer members keeping that information current, as well as those specifiers looking to stack it all up and run the numbers.
Okay, that makes sense. And Jack, a really good point about avoiding the carbon blinkers. We have to see this in all of its complexity, but also keep an eye on the carbon, because up until recently, it's been a bit of a missing piece. Kathy, a question's come in which will really hit on one of your pet topics, or maybe pet peeves, I think, and that is, are there any regulatory or statutory hindrances getting in the way of increasing the sustainability and reducing the embodied carbon in the bricks and in the materials that you're aware of that the working group looks at?
There are, and
really,
one of my pet peeves. That was great segue. Probably one of the biggest barriers is what you're allowed to do as a manufacturer and those controls you have on your manufacturing licenses under the EPA. So those that don't know, if you're to manufacture anything, you've got to have a license to do it. That license gives you so much permission for what happens on your site. Bringing waste materials, so someone else's waste, you might think it's a resource for you, but it's someone else's waste, is not covered under your manufacturing license, and you have to get different permits. And that's not only with the EPA, it's with your council as well, because you're bringing materials on which affects your DAs, your approvals to operate on that site. It affects that. So there's this link, and it can take years to get permission to add a waste product into manufacturing. And it's a real barrier, because if things take too long and cost too much money with consultants, manufacturers just give up because it's too hard and you don't bother persisting. But there's a lot happening, as many manufacturers have. But New South Wales is probably, and I'm going to say this, the worst state for it, because there's many things that we can do in Queensland and in Victoria. And now Adelaide is about to put the wine waste in, and have got permission within quite short periods of time. But New South Wales is a serious barrier to it, which is really disappointing. They talk about decarbonising and using waste materials. We go, well, we can use that. We can use coal. We can use whatever. And then you just can't get approval. So that is a serious barrier.
Okay, so let's work with that frustration in the new year. I know we've been seeking engagement with the EPA, and they're not saying no, they're just busy. But let's keep working on that, because I do think there are competing goods. Let's make sure that they're actually aligned rather than getting in the way of one another. But good point. And I really do like the idea of just drinking a little bit more wine over the Christmas period to make sure that that waste product goes to a good use. I think that's something we can all embrace.
Everyone can embrace that.
That's right. Yeah. Good point. Thanks, Kathy. Cindy, is there much resistance to change if you're looking at different, different products, different using recycled material in some pipes? It'd be good to hear you distinguish between pressured and unpressured pipes, and why you're keeping recycled material out of the pressured pipes. But do engineers or architects or people specifying, are they worried about change when it comes to pipes? And then I'll ask the other guys as well.
So there's obviously a big push to use recycled materials, or in products, not just pipes in general. And what we have seen is, and obviously I spoke about the Australian standards. So again, we do have some of the most stringent Australian standards, and that's a really positive thing, because of the fact that we have that performance. So we know that from materials through to the actual end product, if we can conform to these standards, we know that it's going to last that 100 plus years. And that's through to installation standards as well. So again, if we, don't have those blinkers on and we think about that broader circular economy framework there about designing a product to last a long time. So like I said, we've done a lot of research into looking at material properties, and then, recycled material properties, how they perform going into different pipes. And so there's complexities with, I suppose, using recycled content. If we just talk about PVC pipes, for example. So all pipes they need to make it within the standard, need to be a certain color, and that represents what's going through or what's being conveyed. So once you start using recycled content, if you used it in all the pipe, you could change the color. Then you're going to have to add all these additional materials, and so that's not really, really being sustainable. So we've designed things like multi-layer extrusion technology, where you can actually think of 3 layers. So in the core, we can put recycled content that meets the requirements, but doesn't matter what color it is. And then we put a really thin layer of virgin material on the inside and outside. And so there's these innovation developments. So therefore, then we're meeting the requirements of the standard, and it's still fit for purpose. And we're not adding any additional materials just to use that recycled content. So, that design innovation perspective. As I said, we're in our first life cycle. We don't have enough raw recycled material available to use even within our non-pressure pipes. For pressure pipes, these are the ones that are going to be put under constant strain or pressure. So we need to make sure the material properties for them are known, and that means that full traceability. It's not to say in the future that we wouldn't change the standard, but right now we don't have enough recycled content for non-pressure pipes. So let's tackle that one first, and before we then go into pressure pipes. So as I said, there's a bit of science here. It's just not adding any sort of plastic in. The material properties need to be right so that we do get that long life.
Terrific. Thanks, Andy. That makes a lot of sense. A question for the brick experts and question around all things unfired clay and rammed earth in Australia. Is that getting to a commercial scale, or is that still kind of a home builder, owner builder niche?
It's probably a bit of owner builder niche because it's done on site. Like it's not, they're not manufactured off site, they're done on site. So most rammed earth. There are some people, some manufacturers feeling with small scale production of it. But yeah, it's not on a commercial scale anywhere at this point.
Okay, fair enough. Hey, Kathy, while I've got you, the figure when you were showing the figures for imported tiles versus the neighbour's figure for an Australian tile, is that it was almost 3 times the difference? Is that because of a very conservative number for the Australian tile, or what's the explanation there? I would have thought bringing a tile all the way from Europe would actually add a lot to its emissions per tile.
Yeah, well, it adds a bit. What's interesting, the neighbours value of source, because there's no Australian EPDs, that was their first source of data. Then they went to overseas credible data, and the EPDs were located around the world. Neighbours identified 2 EPDs. One was from India and one was from Malaysia, I think the other one. And they both had very high carbon values in those 2 plants. They're not typical. We actually know there's from the Spanish and European ones that are much lower, and that'd be more typical to what the manufacturer and energy sources we have in Australia are. But at this point, that's how neighbours did their framework with their uplift values and tier factoring. It ended up at that significantly higher number. So we know that's what it is until there's some more better knowledge, and when that's available in the industry, we'll be able to update those figures.
Yep, great. All right. It's pretty good motivation to get the EPD done locally, isn't it? Yeah.
100%, yes.
Yeah, okay. Hey, Jack, one of the questions that's come in around, I suppose, circular economy and beyond carbon sections of the guide, how do you make sure that there aren't any toxic ingredients? You know, the desire for recycling, terrific. But what if the wrong material gets in there? How are you checking off on that? And things like the LBC red list has come in from the question.
Yeah, look, that's a really great question. And I think it's very poignant because that information, I think the beyond carbon part of these templates, we didn't really touch on throughout our presentations, but there is a section within those templates that talks a little bit about some of those additional factors that specifiers need to be aware of. So things like eutrophication potential and other nasties that are going into these products. So at this stage in the templates, it's been included with a few suggested pre-fill forms for those beyond carbon terminologies. So this can range from, as I mentioned, stratospheric ozone depletion potential, tropospheric ozone formation potential. So a few other big sciencey words that manufacturers now go back towards and see how they can fill it in. But I think it's actually a really great opportunity moving forward. So for us as manufacturers and representing manufacturers within our own sustainability guides, it's currently not included in our own guides. This has been something that MECLA's kind of led the way on. So it's a really good way of forcing us when we go as an industry next year to actually update our own internal documents. That's going to be a focus of our discussion, to look at how we actually tell that story. And the good news is for concrete and clay products that we represent is that there is a really good news story there for us to share and showcase and do so in a more clear manner. So the summary is the start of it's there in these MECLA documents, but it's definitely an area that we can upgrade and grow as we update these iteratively.
Terrific. Okay, well, I look forward to hearing more as that iteration takes place. Josephine, if I could turn to you, one of the things that MECLA prides itself on is being the ecosystem. It's not just industry, it's not just government, it's not just research, it's all parties and all the professions and all the bits and pieces in between. What's the research dimension to all of this?
Yeah, I think that a few people mentioned too that the way forward is that we really need to be developing and understanding our impact that built material, buildings, everything is having on the natural environment and on human health. And yeah, definitely on that previous point, that it's not just about embodied carbon or circular economy. Like, the whole reason that we're interested in this is the bigger picture of the planet and the situation that we're in. So having that big picture, that kind of systems thinking approach is really helpful. And I think when you start to work with researchers, universities, or doing your own internal research, you know, really justifying and evidencing what you're doing. But I also think being creative with that research as ways to explore kind of solutions that are based within, you know, the physical parameters of manufacturing something, or what that physical object can do, but also how it works into the wider construction industry. And so that's my real interest, is how it all plays out with, you know, the psychology of who's going to use these products, the economics of it, the materials qualities, all of those things come together, and research can really help with any of those or bring them all together.
Terrific, thank you. Cindy, can I ask one of the questions? Well, there have been several questions in the Q&A looking at asking about pipes. One of the ones caught my eye was around the risk of microplastics. I'm sure not the first person to ask you about that. And
Yeah.
Josephine talked about the broader environmental health. What is the situation with the risk of microplastics leaching from plastic pipes?
Yeah, it's a really great question, and you're right. It's very topical, especially when plastic pipes and microplastics. So there has been some research undertaken overseas in Europe by TEPFA, which is the European Association, similar to Piper, and I work very closely with all of our overseas associations as well. So they undertook a study that was presented at our last global pipes conference around actually measure in a lab, you know, undertaking measuring the potential release of microplastics from plastic pipes. And that research actually came back and said that there was no leaching from plastic pipes. Probably a little bit of an inside scoop here, but Piper has decided to undertake similar research here in Australia. But we're looking at it in two ways. We're looking at it in drinking water, but also release to human, and we're looking at release to environment through stormwater as well. So we've actually teamed up with Griffith University and also RMIT through the CRC. We're at our very early stages, but we're looking to hopefully undertake that study next year and then release the documents. You know, looking at the work that's already been done, again, it comes down to, again, the way that the product is manufactured. I had a quick look at the question on the screen, and so the way that a HDPE liner is manufactured is very different to a pipe. So again, you know, I can't comment on the liners, but for pipes, at the, you know, for the research that's already been undertaken, it shows that there is no release. But I am looking forward to undertaking this research and actually aligning with the ISO standards as well for microplastics, to ensure that, again, everything's put in the right context and the right type of testing is undertaken.
Thanks very much, Cindy. It's clearly a hot topic and something of interest to the MECLA community. So thank you. This one's probably for Jack and Kathy. What percentage of bricks are reused? We see a lot of demolition, and we see, you know, in, I suppose, architecturally designed courtyards and feature walls, recycled bricks get used. But rough numbers, what are we looking at?
Do you want me to go, Jack? I do.
Start.
Yeah, I'll start. It's actually really hard to know, because a lot of it's linked to how you know, when the buildings are recycled. So we know probably the commercial side of buildings, architects will reuse the product, and they might reuse the products in pathways, gardens, etc. Any older buildings getting knocked down, they ring one of the brick recycling yards, and they come and collect the products, clean them, and then can sell them again. When you see houses being knocked down in your suburbs, often you'll see them separate the bricks and masonry waste, so it'll go to sorting yards. Most of that would be crushed and recycled, not reused.
Not reused. Yeah.
It's just a separation thing. So it's a really hard. I don't know if there's any exact number for it. When we talk about the end of life numbers when you do full life cycle assessment, it's actually taken as really low because you don't actually, there's no data being collected now. I think this is something we're working on, a journey that we can actually work out how do we reuse more, how do we recycle more, and how make sure it doesn't end up in landfill. And I did see a question someone asked about recycling bricks with holes in. You can, core holes, you can do it. It just depends if there's a want to do it. A lot of the bricks that are being made in those generations may not be the most fashionable now, so people actually don't want to reuse them. People tend to like the older solid bricks. They do become slightly harder to get the mortar off because of they got cores, so they're a little bit more brittle. But that's how we're working towards these projects, using mortars that can be removed easier, so even those bricks can be recycled into the future. I mean, this is a journey that we're all on. When do you want a building to come down? Is it 60 years? Is it 100 years? How long do you want that mortar to be durable for, to hold that building together? So it's a really important question.
It is, isn't it? And let's be honest, one of the reasons MECLA looks at upfront carbon is because that's where the industry participants have control. The end of life, from a circularity point of view, absolutely vital part of the circle, but it isn't something that, in most instances, is something that the project proponents can control. So I think that's a very fair answer. It would be interesting to see the data if it ever becomes available. Hey, always there's a question about cost, very reasonably so. Most buildings are built by for-profit entities. Say, Jack, I've picked up your guide and I want to do all the right things. Is that going to cost me more?
Yeah, this answer can very quickly turn into a runaway train, so I'm going to try and keep this answer succinct. The short answer is a lot of the time, yes, and I think we have a very big barrier to cross that goes beyond these guides about this healthy balance between education, awareness, cost, and result. So in certain small situations with regards to concrete products, a lot of the time, those supplementary cementitious materials that we're using to lower the footprint of products may not make a large price difference. And for those small wins, that's going to have a smaller impact on the price. When we look at things like changing manufacturing processes to make the whole procedure more efficient, to get more of the way on that carbon or decarbonisation journey, that can definitely have a larger impact. And I think there is a question further down in the chat as well that speaks to this point about, well, these products exist. We do have lower carbon alternates available, and you could sort of see on that flow chart of different carbon numbers that there is a range from quite low to quite high. And what we sometimes see and what we hear from our manufacturers a lot of the time is that some of the groups that are pushing for these lower carbon materials is that when you get to the end result and you have this low carbon marvelous product, is that at the end of the day, it then comes back down to costs, and you've made this product that then does not get specified. And ironically enough, it is a lot of the time those groups that are pushing for decarbonisation at a higher scale that ultimately go down that journey of wanting it and then backflipping due to those cost requirements. And I know that we're in a really difficult time right now with cost of living and requiring a lot of 1.2 million homes to be built. So it's definitely a balancing journey of how far down the decarbonisation journey can we go while still maintaining that cost. So my summary point to this is that everyone should be asking the question when they're specifying these materials of what are the different lower carbon alternatives, because a lot of the time there's more than one, and you can get most of the way to your result without having to sacrifice on those cost initiatives 100% of the time. So everyone should be asking the question, because you might find that there's a compromise that's still a healthy way towards your own decarbonisation initiatives.
Okay, look, for a runaway train, that wasn't such a bad response. Jack, thank you. I think that all made a lot of sense. And yeah, it's like everything else, it's nuanced, isn't it? There's no quick answer, but it's something. It's another one of the factors. I'm very conscious of time. There's one last question, which I think is very topical. Well, there are many questions, but there's one last one I want to throw to you, and that is around the coming mandatory reporting requirements for large Australian businesses and therefore their suppliers as they provide Scope 3 data. Is that context influencing these guides and the movement that's around the work that's gone into these guides? Maybe starting with you, Kathy, and then I'd be keen to hear Josephine's perspective from a research organisation.
Yeah, definitely. And I think it's part of the whole, the change in manufacturing, knowing that this reporting is coming. And obviously, first of all, sustainable ESG reporting in companies, TCFD reporting, and then finally the accounting sustainability reporting. I'm not an accountant, so that bit's a bit beyond my expertise, but those things are all in the manufacturers' minds currently. So as they're working towards what happens, this is all really well documented in the business now. There's no just making up of numbers. I remember back in 2000, I think it was about 2003, someone asked me how much energy goes into making a brick. I had no idea. And it took me 2 years to get credible data. And that's why Brickworks can say from 2005, or we said 2006 to now, what that drop is of emissions, because that data was collected accurately for so many years. It took 3 years to get there. But it's now been done very credibly. Lots of third-party checks and balances going along the way to make sure that reporting can all happen. And those numbers, when we get them, can feed into things like the specification guide and keep that updated as we go.
Great, thank you. Look, we've only got a couple of minutes left. So, but Josephine, from your point of view, the research world is often on the the second or third horizon of innovation and context. Is the move for mandatory reporting, which will trickle through the economy, do you see that as having more than just a compliance component when it comes to materials, embodied carbon?
Yeah, I think maybe a few years ago, well, it wasn't on anyone's radar really. It's now sort of become one of those things that people are really interested to look at. And I think that the experience of industry organizations like taking up embodied carbon values, for example, just reporting the embodied carbon values, has taught a lot of them that actually if you can get involved in the research earlier and build that into the whole process, that the whole thing becomes much easier to do. So we have definitely had a few bits and pieces of interest from the different parts of Scope 3 reporting coming through to the university. I encourage everyone to do research in this area and see how you can use these reportings not as a scary thing, but as something that can really help your industry and to help promote what it is that you're doing for a positive future for buildings.
Terrific. I think that's a great note to finish on, just the value of research and the need for ongoing work. Kathy and Josephine, the work that your working group has done clearly is of interest and of value to our sector. And there's more to come. As I said at the beginning, you'll be hosting another spotlight in the new year with similar guides on glass, bitumen, and plasterboard, other materials used pretty much on most construction projects in some way or another. So really looking forward to that. Thank you very much, Cindy, for dialing in from Poland. And that's a superhuman effort, so really appreciate that, and particularly for the content, not just the presentation, the content that's gone into this work. Jack, to you, that's as well as all of those acronyms, there's obviously a lot of evidence-based data and information in there to help with this change process. Josephine, wearing the researcher hat in the group, thank you, keeping everybody honest and rigorous, very important. And Kathy, I look forward to taking that frustration with regulation and using it to work productively with the EPA on some co-developed solutions. Look, thank you all very much for this. Thank you to our audience for a really engaged session on the Q&A. This whole session is being recorded and like everything else will be up on the resources page of the MECLA website. Now, there is one more MECLA event taking place this year, and it's this week on the 12th, so that's Thursday, in partnership with the Smartcrete CRC, defining embodied carbon. I encourage people to dial into that as well. You can register from the events page on the MECLA portal. But for now, thank you to Working Group 5D. I look forward to seeing this working group and everybody else in the new year. A special thank you to Alexi Barnstone from Climate Kick for making this session happen. He's the one that sends the emails, gets us all aligned, works out the running sheet, all of that stuff that makes this work. So thanks, Alexi. Kati Vahayan also from Climate Kick, thank you to her. And Monica Richter from WWF, the brains of the outfit, let's be honest. Thanks, Monica, and thank you to everybody else. Thank you for your time this afternoon. That's been a really informative session, and I look forward to next year hearing about the other materials. But for now, thanks a lot. That's it. See you next time.